Students, good morning. In the last class, we discussed about the chemical properties of the amines. Okay, in that we discussed about the nitration of amine, bromination of amine. So, and I gave homework for you people, that is sulfonation of amine. No one did. I know that, so I'll do again. So, next one is third one, that is sulfonation of amine. So these are reactions are also electrophilic substitution reactions, students. Okay, so in this sulfonation means there is an idea. H2SO4 we are going to write. If you take this, if we remove OH from this, OH minus, then it will give what? HSO3 plus. Correct? If we remove OH minus from here, we will get HSO3 plus. So this is sulfonate. Okay. So addition of this electrophile to that amine is called as sulfonation of amines. Okay, students. So in that, the first one is, this is the aromatic amine. Okay. If it is treated with concentrated H2SO4 solution. Concentrated H2SO4 solution. Remember, this H2SO4 solution is a dehydrating agent, means it has the capacity to remove water molecule. Okay, so here what happens? This first it will form a salt with that is NH3 H SO4, this one is plus, this one is minus. Here one H is attached here, that is NH3 dot HSO4 minus. This one is plus, this one just H2SO4 is added here. How? One H is attached to this and become plus and HSO4 minus. Then what happens? Then water molecule removes. Okay, so by the removal of the water molecule, so it forms, students, it direct this group here to the para position. They direct the position. It direct this incoming group to para position. As I told you, the para substituted amines are very strong, are stable compared to argon meta. Okay, so listen. So this one is SO3H and this one is NH2 by the removal of water molecule. Okay, so this may be a reversible reaction. If we add addition of water, if we add water, it changes like this. If we remove water, it changes like this. Understand? So this is the reversible reaction. This is a sulfonation of amines. Aromatic amines, it reacts with concentrated H2SO4, gives this type of reaction. So students, if they have sulfonation, you have to write this much. Only this much. Okay. So I write all nitration, sulfonation and chlorination, bromination in the same. You just go and observe what is the difference between them. Okay. So first one is that is bromination. So in that case, students, bromine in water. Bromine in water. Okay. So here what happens? When this aniline reacts with bromine water, that is aqueous, it forms tri-substituted and write group aniline here. This is NH2. Okay, so functional group will remain here. Then what happens? Here form Br, Br, Br. Tribromo aniline will form. So students, here we got tri-substituted amine, but we want mono-substituted amine. So for that, second reaction is bromine in acetic acid. If we take bromine in water, this reaction takes place. If we take bromine in acetic acid, then the another reaction takes place. So first one, so listen, this aniline is protected by reacts with what? CH3, CO twice, O, acetic anhydride. You may write it as acetic anhydride. Okay, students. Then it forms a complex like NH C double bond O CH3. So listen, this is a CH3CO group. How do we write this? Here O is there. Here C double bond O CH3 one side. Here C double bond O CH3 another side. This is acetic anhydride. Here this bond breaks. So this part is attached to this NH. NH2 is there. One H is removed. To that NH, this part is attached. So NH C double bond O CH3. So H from this aniline is there. That is reacts with this and forms CH3 C double bond O OH, acetic acid. Okay. So then, if this reacts with bromine in presence of acetic acid. Okay, so bromine in presence of CH3COOH, acetic acid, what it will form? This para substituted, so this is NH group, it will be like this. Why it is protected, students? Here lone pair electrons on this nitrogen is involved in resonance, results in the formation of this type of complex, because at ortho and para position they create minus charge in the resonance. So to obtain the mono-substituted complex means we have to protect this lone pair of electrons involved in the resonance with the benzene ring. So that's why we protect this NH2 group by addition of this acetic anhydride. Then these lone pair electrons involved in the resonance with these two compounds. So here it involves here, it goes here like that. So it involved in the resonance with this compound, not this compound. So then it easily forms this type of compound. So to remove these, students, again treated with water or acid H plus ion. Okay, so then it will form. So listen, here H2O means it is H plus OH minus, correct? So this H plus combined with this NH2 and form NH2 here. This C double bond O CH3 combined with this OH form CH3COOH. Understand? So this is the reaction. Then has the question, they directly ask you, students, write the nitration of aniline. Okay, if they ask for 2 marks, write this. Asking for 3 marks, write this. Okay, and remember one thing, they used to mention bromine water and bromine in acetic acid. If they mention bromine water, this is the reaction. Bromine in presence of water. If they mention, or they may also say, write the reaction which explains the formation of mono-substituted amines. So mono-substituted means this is the example. So whatever the way they want to ask, they'll ask in that manner. You have to remember tri-substituted means this, bromine water means this. Okay, so bromine in acetic acid means this, mono-substituted means this. Okay, So similarly, next one is nitration. Similarly, like bromination, nitration are also having two steps. So this is reaction with only nitrating mixture. Nitrating mixture means what? The mixture of HNO3 and H2SO4 called as nitrating mixture. Okay, if they react with nitrating mixture alone, there are different types of compounds. So here I write, so this is aniline. When this reacts with HNO3 and H2SO4, it forms three different compounds. What are those three different compounds? So listen, this is NH2 you assume. Okay, students, one will form a ortho substituted, meta substituted and para substituted. So this para substituted compound is 51%, this is 47%, this is 2%. So major product is which one here? Para substituted means that is stable. So we want a mono substituted product. Then, so that we are taking this nitrating mixture in presence of acetic acid as reacts with acetic anhydride, then it forms this type of complex, that is NHC double bond O CH3. So students, this is a amide group. NHC double bond O is a amide group. So further it undergoes nitration, HNO3 in presence of H2SO4. Then it will form para substituted compound. Okay. Again here hydrolysis takes place. When it forms, students, this is the aniline with para substituted nitro group with CH3 COOH. You may write this, or if you left, then also no problem. This is the main reaction. Understand? So the last one is sulfonation. So in this sulfonation, students, there is no need to protect the NH2 group because this NH2 group directly reacts with the concentrated H2SO4. So if it reacts with concentrated H2SO4, what it will form? It form a salt first, NH3 HSO4 minus. I hope you didn't see this. So I write it in this manner. You get NH3 plus HSO4 minus. Okay. So by the removal, by rearrangement, it forms. Here it is NH2, here it is SO3H. Okay, so this may also write, students, here you may write it as bitter ion also. That means this is NH3 plus SO3 minus. This one is called as Zwitter ion. What is zwitter ion means? In the same species, plus as well as minus charge is there. Understand? Here it is plus, here it is minus. In the same species by the accept and the removal of the proton. By the gain of proton, by the removal of proton, if plus and minus charge takes place, then that is called as zwitter ion. Understand? So this is SOOOH type of compound. Understand? So this is sulfonation of amines. Only these three reactions are there, and all these three reactions are very important for 2 and 3 marks. That's why I wrote it clearly on the book. What is the difference in bromination, nitration, and sulfonation? Nothing is there. Final product we got, whatever we got is the para-substituted amine. Okay, but the thing is, without rotating NH2 group in the bromination and nitration, we are getting different compounds, different substituted compounds. Artho, para substituted here, artho, meta, para substituted there. Understand? So, but here, when we protect this amine group by this acetic anhydride, then we will get a stable compound that is para substituted amines. Understand? So, the last topic in this chapter is diazonium salts. Next one is diazonium salts. Okay, students, these are the important compounds of amines. Okay, how these diazonium salts are going to, or how these going to name. So listen, I will write the 2 examples here. One is C6H5N2Cl. Okay, so the name as benzene diazonium chloride, followed by the parent chain, azo group, and also anide. Okay, so benzene diazonium chloride. Next, C6H5N2HSO4 minus, benzene diazonium hydrogen sulfate. Okay, next is C6H5N2NO3, benzene diazonium nitride. Okay, this is the way to name the name of the diazonium complexes. So this is not that much necessary. We are using only this complex C6H5N2Cl, diazonium, benzene diazonium chloride only. Understand? So we are going to study how to prepare the method of preparation and also their chemical properties. Okay, students. So in that, first one is diastolization reaction. The first one is preparation. In that, only one step is there, that is diastolization reaction. Okay, students, what is this diazotization reaction? So, conversion of amines, NH2 compounds to N2 compounds. Okay, here I write amines means NH2 compounds to what? N2 type compounds. That is called diazotization. So, I will take primary amines here, RNH2, especially aromatic amines you will take. Into it. Amine we have to take. No? This is NH2. Okay. Primary aromatic amine especially. So this one is aniline. Example for what? Primary aromatic amine. So when it reacts with HNO2, nitrous acid, or reacts with nitrous acid in presence of HCl at 0 to 5 degree Celsius. Reacts with NaNO2 in presence of HCl and the condition is 0 to 5 degree Celsius, means cold condition. Ice cold condition in this way. Okay, at 0 to 5 degree, the water is in ice form, solid form. Okay, so that is, then what it will form? It will form into Cl minus compound. What it is? Benzene diazonium chlorides. Understand? So students, instead of this aroma you take here, directly write NaNO2 plus 2HCl. Here you write condition 0 to 5 degrees Celsius. Complete reaction today. Primary amine reacts with NaNO2, that is nitrous acid, in presence of HCl at this direction. So then remolar HCl takes place, at HCl H2O takes place. This much is enough. That is what? Benzene diazonium NaCl H2O. Understand? So this one is what? Benzene diazonium chloride. Understand, students? So this is called diazotization reaction. So the definition for diazotization reaction are primary aromatic amine converted to azo by reacting with nitrous acid and HCl, called as diazotization. Okay, students. So this is the definition. The primary amines, the must should be a primary amines. The primary amines converted to azo group by reacting with nitrous acid and HCl, called as diazotization. Okay, so this is only one type of preparation. There is no another way. Only this we will do. Then they will form benzene diazonium chlorides. This is a dye. Okay, how the dye will form, I will explain the chemical reaction. Understand, students? Finished? Okay. So next one is, if the preparation done means the only thing is the chemical reaction. So these compounds undergoes two types of chemical reaction. One is replacement of this into group. Replacement a reaction involving displacement of N2. Two types of reaction. Replacement of N2 group, that is azo group, and second one is coupling reaction. Another one is coupling reaction. So students listen, I will clearly say instead of aromatic compound benzene ring, I will write C6H5 into X minus. Here I will take X minus because I have to say different halogen atoms. Okay. So when they react with, here I will take Cu2Cl2 or CuCl2, Cu2Cl2 only, in presence of HCl. You may take reaction condition here like this, Cu2Cl2 in HCl. Okay, they form C6H5Cl. Okay, plus N2 plus this H and this X, that is HX. Understand? So if we want bromide, you may take Cu2Br2 in presence of HBr. So if you take Br2, you will get C6H5Br plus N2 plus HX. Okay? Next, if you take Cu2Br2 and Cu2I2 and HI. I will not get anything. You take Cu2Cn in presence of KCl. What you will get? C6H5 replaced by this Cn plus N2 plus HCl. Understand? Only the thing is students, whatever the halides you are taking or a negative degree of H you are taking here, that is replaced by this C6H5. N2 dissociates. Correct? That's what I am telling here. Replacement of N2. Sorry, displacement of N2. For a replacement, sorry. Displacement. Displacement means remove. Okay, so this complete three reaction is called as Sand-Meyers reaction. So this complete reaction is called as what? Sand-Meyers reaction. So this is first reaction. Second one, same, consider this C6H5 N2 Cl minus. Here it is plus. If it reacts with Ki, what happens here? This C6H5 is bonded to this I, that is C6H5I plus N2 plus KCl. C6H5 plus I plus N2 plus KCl. Understand? So the next one is displacement by hydrogen. Means we are considering CH3, CO, OH. So I will take CH3, CH2, OH. Okay, students. Here we are getting. So listen. This is C6H5H. C6H5H nothing but C6H6 benzene ring. Okay. Next, here Cl is there. One H is here. Here N2 plus HCl. One H is combined here, that forms C6H6. Another H combined with Cl, form HCl. N2 remains. The remaining is CH3, CHO. That is aldehyde. Understand? Here, one H is combined with this C6H5 form 1C. Another H combined with this Cl gives HCl. N2 displacement remaining is CH3, CHO. Okay, students? Another one you may take C6H5 into plus Cl minus plus HbF4 hydrogen borofluoride. Okay, then it will form C6H5F. Okay, plus BF3 plus HCl plus N2. Here one F combines here, H combines here, form HCl. Remaining is BF3 with the displacement of N2. So this is all about the reactions which shows the displacement of the N2 group by the respective group. So this is displacement by iodine, this is displacement by hydrogen, this is displacement by fluoride, this is displacement by fluoride, bromide and cyanide. So by adding any other nucleophile, especially all are nucleophiles here. Understand? By replacing by the addition of any nucleophile or by displacing the nucleophiles, we will easily displace this N2. Understand? This is a one type of reaction. What is the reaction? Displacement of nitrogen group. Another one is what? Coupling reaction. I hope you understand this. Only the thing is, always whatever the cationic species are here, students, that is bonded to what? Benzene ring. Understand? So if it is bonded to benzene ring, N2 is easily dissociates and HX will remain. So here X is here. Understand? So this is all about the displacement of nitrogen. Next we will study the coupling reaction. Okay, students. So what is this coupling reaction? Means, so listen, here in that. So one amine compound or an azole compound you may assume. So C6H5 NH2 X type of compound coupled with another molecule or another compound. So I'll write the example, then you will get to understand. You know, this is C6H5. Correct? N triple bond N Cl. This one is plus. This must be plus. This must be minus. Okay. So this is a one type of coupling reaction. Next, here what happens when it reacts with phenol. You know, if nothing is there, your hydrogen is there, correct? Understand? So this is C6H5OH, right? Where is that H? Here. Understand? So here what happens? What is this coupling reaction? This HCl removed from here. Okay? Then it continues as what? First this compound. N is there. It becomes double bond. Again N. So HCl removed from here means next bonded is this compound. And this is OH. OH. Understand? So here this azo group form a couple with these two compounds. That's why this is called as coupling reaction. The compound name, students, so listen, this is the nitrogen means this is ortho, meta, para. So this is para hydroxy azobenzene. Para hydroxy azobenzene. Understand? So here, if you want the explanation, when benzene diazonium chloride undergo coupling reaction with phenol. Okay, it forms para hydroxy azobenzene. Okay, students, para hydroxy azobenzene. So listen, this is an orange colored dye. This is an orange color dye. Okay. So the next one is similarly. This is the first reaction. Another one reaction is there. First I write the reactant. Then you came to know what is the product. Here it is. N triple bond N Cl. This is plus. This is minus. With NH2. Here it is H. So students, these two will remove means I hope you write the product. Okay, if you remove this HCl, I hope you can write the product. So the product is N double bond N single bond. Here NH2. Correct? So here students, here as we wrote para hydroxy azobenzene. Here in the place of OH, what is here? NH2 is here. So here OH is there, that's why we taken hydroxy. Here NH2 is there, that means para amine no azo benzene. Okay, and this is a yellow color dye. Dye means a color. Dye means a color. Okay, so this forms a para hydroxy azobenzene, a orange dye. This forms a yellow color dye, that is para amino azobenzene. So one marks it is important. What is the formula of orange dye? What is the formula of yellow dye? Formula is para hydroxy azobenzene. This is para amino azobenzene. You have to remember this one more. Okay. So what is this coupling reaction? When benzene diazonium chlorides undergoes coupling reaction with the phenol, it forms a para hydroxy azobenzene. Coupling means they form a couple with the two different compounds. Understand? That's why this is called as coupling reaction. Understand, students? So this is one is displacement of nitrogen group into group. Another one is coupling reaction. These two are the reactions, are the chemical properties of diazonium salts. Okay. So conversion of amines to diazonium salts is called as diazotization test. You have to remember this. So this is about the chapter amines. So this completes the chapter amines. As I told you, this is important for 5 minutes. Okay. So students, in that whatever the neighborhood reactions are there, like carbalamine reaction is there, Gabriel-Thalamine reaction is there. That type of neighborhood reactions is very important for 2 and 3 marks. Understand? At the same time, the nitration, bromination and sulfonation are important. All the preparations and all the chemical properties are important for 2 and 3 marks. And also, nomenclature is important for 1 mark. Nomenclature, at the same time, melting point, boiling point, their solubility, okay, and what is the reason for that. Understand? So this is all what comes under the amine chapters. So this completes the chapter amines. In the next class, we will discuss with the next chapter. Thank you.